The topic that we are going to cover today is Java Layout Manager. Now, Java Layout Manager determines how the components are going to get arranged on your applet or on your frame. So, suppose we are designing an applet or we are designing a frame. You get a lot of buttons or a lot of other components like text fields, radio buttons, checkboxes, so on and so forth on your applet. Now this layout manager determines you, or using the layout manager you can specify how the components are going to get arranged on your Java screen. Now, what are layout managers? Layout managers are nothing but interfaces, and this interfaces needs to get implemented in your program. Correct? Now, there are 5 layout managers that we are going to discuss today. First is border layout. Now, what happens in case of a border layout? A border layout looks like this. Now, you can see in this applet, we have added 1, 2, 3, 4, 5. There are 5 buttons that has been added in this applet. And the 5 buttons that are added in this applet are arranged on the screen in 5 regions, which by border layout is called north, east, west, south, and center. Now, when we are using frame or window, I repeat again, if we are using frame or window, border layout is the default layout. When we are using applet, the default layout is flow layout, which we will be coming shortly. Now, so therefore, in case of border layout, the elements or the components are arranged in 5 regions: north, east, west, south, and center. And the size of these components are determined by the border layout manager itself. So over here, as you can see that the center button is taking up the maximum area on the screen. So this configuration of the components on the screen is determined by the border layout itself. Now, let me show you how this border layout is implemented in a Java code. This is the code. You see border layout first. Over here, let's come to this statement. This statement over here creates an object B of the border layout type. Clear? So, B is an object of border layout type. You see there is no parameter that has got passed to this constructor. So the constructor of border layout is a non-parameterized constructor. No parameter needs to be sent when object is created. Clear? Now, obviously, this is the statement using which you set the layout of your screen to border layout. Now, the most important part is this. Over here, we have used something called south, east, west, center. Border layout dot south, border layout dot east, border layout dot west, border layout dot center, and later on, okay, on the top we have used border layout dot north. Now this border layout layout dot north. When we are writing, you can see that this north is written in capital, right? Same goes for when we are trying to write border layout dot east. Now, all the 5 regions, north, east, west, center, and south, all these are static values in border layout class. All these are static in nature. These are all int static type of values. When we want to put any component in the north region of border layout, we have to use the statement add. This is the name of the component and this is the border layout region where we want to place the component. Again, if we want to place a particular component to any particular region of the border layout, we need to write add, then within bracket the name of the component, comma, border layout dot the region in which we want to place, and that region should be written in caps because all these are static final values in border layout class. Again, I will repeat, all these are static final values in border layout class. Fine. So therefore border layout divides our region on the screen into 5 regions, and all those regions can be applied to the component by writing border layout dot the name of the region, and the size of the components on those regions are determined by the border layout configuration itself. We do not mention any size. Center region takes the maximum of the area on the screen. Clear? Next, the next layout that we will be talking about is grid layout. Next layout is the grid layout. Now, grid layout topic, I had covered a bit of grid layout topic before as well with you. Now, we are going to extend that discussion, and I'm going to discuss few more properties of grid layout. Now, the first basic property of grid layout is that grid layout divides the screen into rows and columns. Grid layout divides the screen into rows and columns. You see, this is an example of grid layout. I had shown you this example before as well. So you see over here, the region or the screen has been divided into 3 rows and 3 columns. 3 rows and 3 columns. These are the 3 rows and these are the 3 columns. So it has been divided into 3 rows and 3 columns. Now, there are 2 types of constructors that are available with grid layout. There are 2 types of constructors that are available with grid layout. First constructor is non-parameterized constructor, where you give, when you are creating grid layout object, grid layout G is equals to new grid layout and you do not give any or pass any parameters. You do not pass any parameters. This is one of the constructors of grid layout. It is non-parameterized. And the second type of constructor that is available for grid layout is where when you are creating an object of the grid layout, you pass two parameters. You pass two parameters. One is number of rows, another one is number of columns. One is the number of rows, another one is the number of columns. So the first parameter that is passed is always the number of rows, and the second parameter that is passed is number of columns. If we check in this example, over here when I have created the grid layout, you see I have used the parameterized version of the grid layout constructor where I have written 4,3, and so my grid layout would have 4 rows and 3 columns. It would have 4 rows and 3 columns. Clear? So grid layout gives us a screen in row and column format, and it is divided into small cells. Now as we go on adding the components are added one by one onto the cells. The components are added one by one onto the cells. Now, it is important to note that you cannot determine a particular cell for a particular component. That means you cannot specify a particular cell to put a component inside it. As you go on adding the components into the grid cells, the components are added one by one. Cells cannot be specified in that case. For the cells cannot be determined for one particular component. Now, grid layout, this is non-parameterized constructor, this is parameterized constructor. Now, inside this parameterized constructor of grid layout, we have another type of parameterized grid layout constructor, and that is where it takes 4 parameters. It takes 4 parameters. One is row number, column number, that remains the same. After that, it takes a value for something that is called horizontal gap. And the fourth value is vertical gap. Now, what do we mean by horizontal gap and vertical gap? Horizontal gap means the amount of gap that will be present within the elements or components which are put in the grids. This example that I had already shown you, let us put if you see that there are no gaps in between the cells that has been created. There is no gap between the cells that has been created. All the cells are coming one after the other. Correct? Now, if we use the second parameterized constructor to create this same grid, let us see what will happen. The same grid I am creating over here, the same constructor I am calling 4, 3 with age gap as 5 and vertical gap as 5. H gap as 5 and V gap as 5. So again I'm telling you, vertical gap and horizontal gap means that the distance that the components will have between them horizontally and vertically. So let me run this. As I run this, now you can see the same layout, but you can see that there are spaces in between the components in the grid. There are spaces in between the components in the grid. So this is what H gap and V gap stands for. Correct? Now, before I proceed further, I would like to give an example where this grid structure and the border layout that we did previously can be clubbed, and we can create a different type of layout as we want. Now, as we have discussed the border layout divides the screen into 5 regions, and in each region we give one component. In each region we give one component. And what is grid? Grid layout is where we create rows and columns and we put components in each of the cell of the grid. Now, look at this particular layout. Now, if you look at this particular layout, you can understand that I have used a border layout over here. But if you look at the north, you see there are 2 buttons in the north. In the north region of the border layout, there are 2 buttons. But each region of a border layout only allows 1 button. Then in that scenario, how can we add 2 buttons to one of the regions of border layout? Right? That is where our grid layout and border layout is combined to bring about this effect. Okay, let me show you how it is done. For having that effect, effect of border layout and grid layout together, here I have taken a panel. Now, what is a panel? Panel is nothing but a container that can contain certain the components of the AWT components. Panel is a container that can contain AWT components, right? So, a panel has been created over here, and if you look at this statement, in the north region of the border layout, I have added the panel. I did not add the button to the panel, button to the north region. I have added the panel to the north region. Now, what does that what effect does that give us? When we are adding a panel to the north side of our border layout, this panel can contain, it is a container type component, so it can contain its own layout pattern, it can contain its own components. So it is like a total separate sector inside the applet. Panel is like a totally different sector in the applet. So it has got a configuration of its own. So we can add layout to it, we can add components to it. So I have added the panel to the north side, and after adding the panel to the north side, I have created another button. Let me call this button north northeast and this button as northwest. So I have created two buttons, and now if you see, these two buttons northeast and northwest has been added to the panel. So I have created the panel and I have added the panel to the north region of the border layout. So the north region of the border layout has a different sector, so it can, and that sector can contain its own layout form. And what is that layout form? That layout form is the grid layout. So I have created a grid layout of two columns and one row. I have given a horizontal gap of 5 and vertical gap of 0. Since there is one row only, no vertical gap is required. So I have created the grid layout and I have written f.set layout G. That means the layout of the panel is grid type and layout of the whole applet is of the border type. Correct? Now the buttons have been added to this panel. So when the buttons have been added to the panel, now the buttons take the grid layout pattern and each of the cells in the grid carries one of the buttons, giving us this particular effect that we just saw. So these two buttons are inside the panel and panel is in the north region of the border layout. So what is the reason for this example? I showed you this example to tell you that if you are designing an applet and you want to change your design, you need not become slave to the layouts that has been given to you. You can customize the layout by combining more than one layout and you can create your own design on the applet. Clear? So I think you have understood how to combine different layouts using panel. Now we come to the next layout, that is the flow layout. Now we come to the next layout, that is the flow layout. Now this is an example of a flow layout. As you can see in the applet, the buttons are coming one after the other. This is an example of flow layout. Now this flow layout and card layout we will be covering in the next layout video. Okay, thank you.